in one way or another, we got coal, right? Talked about different methods, strip mining, mountaintop removal, and those sorts of things. So we're going to shift gears and actually talk about the next phase, right? Once we have the coal, load it in a train, do whatever sort of transportation mode that we use. Generally, it's train cars with coal. There's these famous scenes of coal cars, linked up driving out of Wyoming. That's actually the opener for your blackboard class. It's these train cars full of coal. But then that coal gets to a power plant, and I know this drawing looks like I've got a lot, but we're gonna kind of slowly work our way through this drawing and really see how a coal-fired power plant works. And the reason why I want to take a little bit of extra time and go through this particular example is all of the other types of power generation that we're going to see from now on are going to fundamentally work the same way. Although what we'll find is that the source of energy is different, right? So you could say there's an incredible similarity between a nuclear power plant and a coal power plant. You could actually say that about a lot of types of power plants. So we'll spend the extra time going through, kind of working our way through our coal power plant here. So let's do precisely that. And I'm going to kind of be drawing along. Hopefully you can follow me. So the first thing that we need to do is we need to get some coal, right? So we did that. Yay, we've got our coal here. It's all loaded. I drew it in this little hopper. And this coal is then brought in to what's called a furnace. So this kind of area right here that's got a lot going on will be known as the furnace. And the fundamental thing that happens there is, well, first of all, that's where coal is burned, right? So you can see that's what my little pile of coal is doing down here. I drew some red flames. So we dump our coal in there. Keep in mind, I'm always simplifying this stuff. We set that coal on fire, and it burns. That's what coal does, right? It's the rock that burns. It's its most famous characteristic. But now we bring in something to capture the heat created from burning that coal, and we generally just use water. So if you're going to build a coal-fired power plant, you're going to want to build it near a river or a lake or a reservoir of some sort. And what we do is we pull water in from that source and bring it essentially into the furnace. So this blue line is going to represent our water going in. Water is coming along. Water is going to become really important. Goes up. In some cases you could have a reserve tank. So this is filled with water that we've pressurized. And then the water is pushed through. This is something called a heat exchanger. And like I said, we're going to come back to these quite a bit. But it's, to simplify what a heat exchanger is, it's a convoluted set of pipes that the water runs through that's encased in the furnace. So the water doesn't necessarily come in direct contact, but as the water is flowing through these pipes, as you can see here, keep in mind this furnace room is hot. So actually I can go through, let me grab my red pen, and I'm actually just going to color in the entire furnace room so it's really clear to you what part of this is hot. Okay, hot furnace, right? So I filled it in red, and you can clearly see that there's this path of water that goes through that heat. So by the time the water leaves that furnace room, when the water's coming out the top here, it's really hot. And actually, we keep this under pressure, and you can heat the water up far beyond the boiling point of water. It's actually how a pressure cooker works, right? So in a pressure cooker, if you've ever used that, you could easily get water up to 300 or 400 degrees because it's kept under pressure. And so that's exactly what happens here. So our water is pressurized in these pipes, and it's traveling out. It leaves the furnace area, but remember now it's super hot water, and it comes into the next part of the building here, which would actually be what we would consider the power plant itself. And again, here, this is one of the things that you're going to find in the case of the power plant is this is really the standard. This is actually where the magic happens. This stuff can kind of change as we look at other power sources. So our water comes out in the power plant, and I left a lot of detail out of this. Essentially, it's depressurized, and when it comes out, it flashes to steam, meaning it expands a lot. And so we use the force of that steam, just like the force of a steam will blow a tea kettle, or the force of the steam will, drive a locomotive. Here, the steam actually spins a turbine, which is, again, if we want to really strip it down and kind of get simple, it's kind of like blowing on a, what is those things my kid has? Like a little pinwheel, right? So you can imagine if you blow on a pinwheel, it spins. So here we've got a lot of steam and a really heavy pinwheel called a turbine. So it spins that turbine, which, again, essentially spins the magnet, right? So we've got copper wires and we've got a magnetic field. So that should, start to bring up some memories from a couple of weeks ago. And at that point, the spinning action of the copper wire mass and the magnetic field, as that's moving, the magnetic field's in flux and it creates a flow or an electric current. And at that point, we've created electricity. We did it, right? We're there. Now we can turn the lights on. So the next thing that happens is you have all this steam. It's a pretty wet environment. So that steam then condenses. Again, I'm kind of leaving out some of the details, but my hope is that you just really understand the fundamentals here. And as the steam condenses, it turns back into water, and that water is run back out to its original reservoir. It's cooled off along the way, hopefully, right? So in some cases we have cooling towers, which, nuclear really is famous for the cooling towers, but coal has them as well. And then the whole process starts again. So fundamentally what we're looking at here is the furnace where the coal is burning, heating up this water past the point of vaporization where it will flash to steam, flashes to steam, spins a turbine, that creates an electric current, that runs off onto the power grid, water's condensed, and that's the whole thing. One of the things that we're going to explore a little bit on the back end when we start talking about problems with coal is this bad boy, right? So we have this coal fire going in here, and there's essentially a smokestack that coal, the volatiles that come from burning that coal go out the smokestack, right? Along with aerosols, some things called fly ash. On the lower side of our furnace, we also know that depending on the type of coal we're using, it's not going to burn cleanly, right? So we talked about the different grades of coal from peat all the way to anthracite, and we talked about the different carbon percentages. Remember, we burn kind of what we call bituminous or subbituminous coal, which is in the 80 range. I would say anywhere from kind of 65 to the mid 80s, depending. Of carbon content, meaning the remainder is residue, it's residual, it's left over after the combustion occurs. And so then that produces coal ash. So just like, imagine doing this with wood, right? Doing this with cellulose. If you had this endless fire going on, occasionally you'd have to pull material out, right? Because that ash would pile up over time. And so that the two primary waste products that occur are the volatiles that go off into the atmosphere and the coal ash which sits in the bottom of the furnace. In a perfect world, the water never actually touches the coal, so the water should stay fine, right? The water should be basically the same stuff that came in, although it's probably sterilized at that point. So all the little critters living in it probably aren't doing so good. But again, just to reiterate, the two main sources of residue are the volatiles that go off in the atmosphere and the coal ash that sits in the bottom of the furnace.